Among the many ways in which wildflowers have adapted to their pollinators, one of the most intriguing is the way in which they have come to regulate their opening hours. You see, there's little advantage to a flower remaining open if the pollinators are not on the wing, or if insects that are more likely to damage the plant are abundant. In particular, if there are numerous ants about. You see, desirable bees are very early risers, but the undesirable ants, they are not out and about until later in the day. So many wildflowers have adopted quite strict opening hours. Now, few wildflowers demonstrate this behaviour more than members of the dandelion tribe of the daisy family, of which the timekeeper par excellence is goat's beard, or Jack go to bed at noon, as it is known particularly in parts of England, which opens at dawn and closes promptly at 12 o'clock. It's a plant that grows in overgrown roadside verges, very much as you see here. This would be a very typical habitat for it. Not particularly eye-catching because few flowers on any individual plant are visible at any one time, and the foliage is distinctly grass-like, which is an adaptation to the overgrown grassy habitats that it grows in. And then if we look at the individual flower head, you'll see, here it is, there are 8 bracts forming what's called an involucre, enclosing the entire flower. And if we look at an unopened flower here, you can see the way in which they close tightly around the flower head before it opens. Yeah? They're pulling back slightly. They're a little bit longer than the petals, as you can see there. And then after flowering, once pollination has been achieved, they will close again, as you can see here, protecting the seed head until it's ready for dispersal. Inside that involucre of 8 bracts, you have 20 to 50 tiny florets, each a complete flower with 5 fused petals forming a corolla tube, 5 fused anthers and so on, and the piston presentation mechanism of the pollen that we see in dandelions. And this is something that we look at more closely when we come to look at how the dandelion flower itself is pollinated. So after pollination then, what happens is that the flower head closes over again, and as the seeds develop, it produces this glorious seed head. After fertilization has taken place, the seed head closes over, as you can see here, and the flower undergoes a remarkable transformation. Now, of course, the development of the seed is itself an absolutely remarkable process, but one of the most striking aspects of it is what happens to the sepals. In the flower head, the sepals around the individual florets are insignificant little rings of hairs. But once the seed head closes and seed formation begins, they undergo a remarkable change. They become these gorgeous little parachutes. More complex structurally than in dandelion, because you can see here the radiating rays, the struts there, they're joined together by a web-like structure. So it's a stronger parachute, as it needs to be, because it has to lift, as you can see, a somewhat heavier seed. And what's so remarkable about this is to think that those 40 little parachutes with that elaborate structure have all developed tightly furled up within this head here, tightly bound by the 8 bracts. And then in a matter of minutes, it has opened out without a hair being out of place. And it's not as if there's a single umbrella wrapped up in here. It's like as if you have got 40 umbrellas all wrapped up in a space you think would hardly hold one. The name goat's beard is sometimes said to derive from this kind of hairy appearance of the seed head as a whole. But my daughter Jane, who is filming this, thinks it's more likely to be derived from the distinctly goatee beard-like appearance of the developing seed head. In the past, the parsnip-like roots of goat's beard and the asparagus-tasting stems were used as a vegetable, cooked vegetable. And among the several herbal uses, one of the minor ones, which is the one that always comes to mind when I think of this, is its use in lightening freckles. In conclusion, I should say something about the control of this extraordinary timekeeping schedule. You see, it isn't simply a question that the plant is responding to changes in the environment, changes in temperature, light intensity, etc., and then it opens and so on. There is an inbuilt program in the plant's metabolism which governs this, which controls all of this. You can think of it as a computer program, except that here it's biochemical, and then that program is cued to changes in temperature, duration of light, and so on. And one result of this is that the plant is extraordinarily difficult to get in seed, because it only opens, and it opens within minutes, when conditions are absolutely optimal for the spreading of the seeds. And then, in a matter of minutes, they may be gone if conditions are at all windy. So I've been waiting for ages for this particular privilege.